other intelligent life in the universe. Humanity has always looked upward with a double hunger to understand the universe and to find itself reflected somewhere within it. For most of history, the question, are we alone, belonged to philosophy, religion, and poetry. Today, it belongs there still, but it also belongs to astronomy, planetary science, chemistry, and biology. We no longer ask the question from a position of ignorance alone. We ask it with telescopes in orbit, spacecraft crossing the solar system, laboratories simulating alien atmospheres, and catalogs containing thousands of planets beyond our own. NASA's confirmed exoplanet count has now passed 6,000, and the NASA Exoplanet Archive lists more than 6,100 confirmed worlds. That fact alone changes the scale of the old question. Intelligent life elsewhere is no longer a fantasy attached to a few stars. It is a scientific possibility spread across a galaxy dense with planetary systems. The modern search for other intelligence begins with a humbling discovery. Planets are common. The Milky Way is not an empty archipelago of suns, but a place where worlds appear to form as a natural consequence of star formation. Space agencies now treat exoplanets not as curiosities, but as a central scientific frontier, with missions designed to study their sizes, orbits, atmospheres, and potential habitability. ESA describes exoplanet research as a major long term effort, and NASA's astrobiology program explicitly frames exoplanets as places where scientists are trying to assess habitability and search for biosignatures. Yet, abundance is not proof of life. A planet is not a civilization, and a habitable environment is not a thinking species. Between rock and radio lies an immense chain of contingencies. Water must persist. Chemistry must organize itself into metabolism and replication. Life must survive catastrophe. Evolution must produce complexity. Complexity must produce cognition. Cognition must produce technology. Technology must endure long enough to become visible across interstellar distances. This is why the question of intelligent life remains open even in an age of exoplanet abundance. The universe may be fertile, but intelligence could still be rare. NASA's discussions of the Drake equation emphasize exactly this point. The framework is useful not because it answers the question, but because it divides ignorance into parts that science can attack one by one. The brilliance of the Drake equation is not that it predicts a number, but that it transforms wonder into research. It asks how often stars form, how many have planets, how many of those planets might support life, how often life begins, how often intelligence emerges, and how long communicating civilizations last. Some of these terms have become far less uncertain in recent decades. We know vastly more now about stars and planets than Frank Drake did in 1961. But the biological and civilizational terms remain deeply uncertain. We may discover that life appears readily wherever conditions allow, or we may discover that the leap from chemistry to biology is so improbable that the galaxy is mostly silent. We may learn that intelligence is an adaptive marvel or an evolutionary accident so rare that it has occurred only once in our galaxy. The equation remains famous because it reveals the true scale of the mystery. The silence of the sky could mean emptiness, rarity, distance, or simply that we have only just begun listening. Science therefore proceeds on two fronts at once. One front searches for biosignatures, signs that life exists or once existed, whether microbial or complex. The other searches for technosignatures, detectable evidence of technology, such as radio transmissions, optical signals, industrial pollutants, engineered structures, or unusual patterns of energy use. NASA and SETI researchers both describe technosignatures as traces of technology that might be detectable from afar, especially on exoplanets we cannot visit directly. This distinction matters. The first alien life we detect, if we detect any, will probably not be an interstellar civilization speaking to us. It is more likely to be indirect evidence, a suspicious atmospheric chemistry on a distant world, or a microbial environment in our own solar system. Even the Royal Society's scientific discussions of extraterrestrial life have emphasized that realistic first detections are more likely to involve non-intelligent life than dramatic contact with advanced beings.